Welcome, friends. So, let us start with the new topic that is deflection due to bending. So, what exactly the meaning of this term is? So, for that, earlier we have discussed about the beam. Let's say if this is our beam A B and the neutral axis, the axis where the elongation or the compression is zero, mean to say there is no elongation or the compression in that part, so that surface is known as the neutral surface, and the this particular axis, we can say here it is the neutral axis, we can say it's neutral axis. Okay, so to understand, if we will apply the load on this particular beam, so what will be the change there? It will bend. Okay, so let's consider a part of this beam. So if load will be applied, so it will form an arc like this. So for that, if the angle will be phi, and the curvature rate, which the curvature is formed, so the radius of the curvature can be we can represent it by radius r or the rho or any of the terminology. So let me draw the bending segment of this beam. So what kind of the structure you will have? So now if the beam is bent, so then it will be like this. Okay, and if it will form this is the one segment we are considering. So if this part will form an angle phi here, so this is phi, we can say, and the neutral axis is where it is in between the compression and the elongation layer. Okay, the first and the last layer. So here we can say, if this is the radius, so the radius of the curvature is represented by rho. Either we can represent somewhere in r, in the terms of r also, and the angle made by the by this curvature at the center is represented by the phi. So let's say the bending moment due to this, here in this direction it is mb for this particular section, and for this section it will be, if it is clockwise, then there will be the counterclockwise, and it will be mb again. Okay, so it is displayed in this figure. uh, so the deformation, basically the deformation is shown in this figure. Okay, the slope will vary at each and every point. Okay, so for that, let us consider a small part for this. If we are considering here this point, so it will be like this in this direction, and here it is the phi. Okay, and like this we can say. So let me draw this particular segment of the slope of that, how it will vary. So for that, let me draw some another figure. So for that, this small part we are considering, so we can say, if like this, so here it is the like this. Okay, so this is our phi. So this part we are considering. So let's say for this particular diagram, if we draw the xy plane. So if we draw the xy plane for this small segment, so let me draw it here. uh, this is the xy plane, and if the slope is like this, the small segment we are considering that ds. and this is our dx, this is phi, and this part will be dv. Okay, so if the deflection is dv. Okay, so this slope of the neutral axis, it is equals to the what exactly the, so simply directly we can write here, it is the slope of the neutral axis, it is dv by dx. Okay, and that is what dv by dx, that is tan phi, we can say. Okay, so we can write this equation or this term as, again if we will differentiate this term with respect to s, so that is d by ds, and dv by dx is equals d by ds tan phi. So rearranging the terms, we can say it's d2v by ds dx, that is equals to d by ds tan phi. If we can multiply here by the term as it's dx, so here it will be dx2, like this we can write it. Okay, so let me write it in the some new form, so that is d2v over dx2 and dx by ds, that is if we will differentiate this term, so what will be the value, so that is sec square phi and d phi by ds. Okay, so we can write, we can rearrange this term and we can find out the value of this d phi by ds. So let me write it here now, because the board is very small and I have to arrange the space on the board again and again. So here we can write d phi by ds, and that can be written as this term. So this is sec square phi, so it will be cos square phi in this on the left hand side. So simply you can write uh, as d phi by ds, that is equals to this term and cos square phi. Okay, so let me write it, it's d2 square v by dx2 into dx by ds dot cos square phi. Okay, so this is our equation number 1, we can say. And we know that 1 by radius, so 1 by r we have used in my previous videos, and here the radius is considered like rho, so we can say 1 by rho, that is equals to d phi by ds is equals to mb upon e I z z. So this is the moment of inertia, and for this, and so previously we have discussed a lot about this derivation we have derived in terms of these variables. Okay, so simply if we apply some simple trigonometry, so let me draw again the same structure to understand you people. It was our dx, and here is dv, and it's ds, this is phi. So we can say cos phi is equals dx by ds. Okay, so by some simple trigonometry we know that cos phi can be 1 upon 1 plus tan square phi to the power 1 by 2. So like this we can write. So we have the value of this cos phi from this by simple trigonometry. So let me put the values here, this value in this equation. So what we can write, that is simply dx by ds is equals 1 upon 1 plus what is tan square phi. So the value of tan square phi earlier we have determined. So what was that? So tan phi was the dv by dx. Okay, dv by dx we have determined in the previous section. Here also you can see in this diagram. So you can write here the value of this dv by dx. So what exactly it is? dv by dx square to the power 1 by 2. Okay, like this we can say. Okay, and let's say this was equation 1, this is 2, and this is our equation number 3. So if I want to more simplify this equation, so here this term is what? This is dx by ds. Okay, so the value of this cos phi we have find out. So here in this equation again, if we will put the value of this ds by dx here, so it will be the cos cube phi. Okay, so we can write it as in place of this term, it's again here we will put the cos phi. So cos phi and cos square phi, though, so we can write it as cos cube phi. Okay, so this is our equation number 1 now. And in this equation, if this particular value here from this equation cos phi is equals like this, so from this particular value we will put here in equation number 1. So from equation 1 and equation number 3. Okay, so third we can put the value here in equation number 1. So what will be the result now? Let me erase this part and put the value in equation number 1 in place of cos cube theta. So what will be the result now? So here I need to put the value, this value, so that is 1 upon 1 plus dv by dx. Okay, whole square to the power half. So this value we can put, this value we can put here. So let me raise this step also. And now, so by this equation, when the slope angle phi is very small, this the phi angle phi is very small, therefore the uh, dv by dx is also small. Okay, so this term will also small. If this term is small, so the square of that, this term we can neglect. Okay, so this term can be neglected. So if we will neglect this term from this equation, so what will be the result? So this term is neglected, and so finally this will be almost 1. So we can write that d phi by ds, that is almost equals to the d2 v by dx, to this term only. Okay, so this is our equation number, I think that was third, it was fourth, and it is our equation number 5. Okay, so from equation number 2, where we used the term of the mb over e iz. Okay, so from equation number second, equation second and 5. Okay, we have we have the relation here in place of this d phi by ds, we can replace the value that was simply the mb over eiz. Okay, so let me write the value of this d phi by ds from equation number 2. So that was simply mb upon e I z z. So that is equals to this term we can say d square v by dx2. Okay, so by this we can write as mb is equals to d2v over dx2. This term will be here now, e I z z. Okay, so by this. So this is our moment curvature relation. Okay, we have this from EIZZ, so that tends to, it can be known as the flexural rigidity. Flexural rigidity or bending moment. Okay, so like this we can say this is our final equation, final result, that can be, it can also be known as the moment curvature relation. Okay, thank you, thanks for watching the video. For any suggestion, you please comment on my comment box, so that we can have some better videos for you people. Okay, thank you.